Welcome to a new episode of Warzone. Imagine an aircraft so stealthy, it could slip past the most advanced radar systems undetected. Enter the F-117 Nighthawk, the world's first operational stealth fighter. But how did engineers create this game-changing aircraft? Today, we'll dive into the secrets and science behind the F-117's engineering marvel. Before the F-117 aircraft relied on speed, altitude, or firepower to avoid being shot down. But in the 1970s, a groundbreaking idea emerged. What if we could make a plane invisible to radar? This would require not just an advanced design, but a complete rethinking of aerodynamics. Engineers started by studying radar waves. The goal was to create a shape that wouldn't reflect radar signals back to enemy radars. This led to the iconic angular, diamond-like design of the F-117, a shape carefully calculated to scatter radar waves rather than reflecting them back. Creating a stealthy shape wasn't just guesswork, it was advanced mathematics. A Soviet scientist named Pyotr Ufimtsev developed key formulas in electromagnetic wave theory. When American engineers stumbled upon his work, it became the foundation for calculating the radar cross-sections of complex shapes. Engineers at Lockheed used his equations to simulate how radar waves would interact with the F-171's body, allowing them to fine-tune its shape for minimal radar visibility. But stealth isn't just about avoiding radar. The F-117's engines were designed to mask heat emissions, making it harder for infrared sensors to detect. Its exhaust ports were specially angled and shielded to minimize the heat signature, reducing visibility to enemy heat-seeking missiles. Engineers also placed the engines inside the fuselage to further reduce heat emissions and noise. The F-117's top speed was limited, but this was a trade-off the engineers accepted to keep it nearly invisible. The F-117's skin is covered in radar-absorbing materials, or RAM. These materials absorb radar waves, converting them into heat instead of reflecting them back. Engineers developed advanced composite materials to coat the aircraft, and this lightweight radar-absorbing layer was essential for stealth. The F-117's unconventional design wasn't very aerodynamic. To counteract its instability, engineers implemented a fly-by-wire system, where computers assist the pilot by making constant adjustments to the flight controls. Without this, flying the F-117 would have been nearly impossible. This digital control system allowed the aircraft to fly stably, even though its shape and design weren't naturally suited for flight. With a fly-by-wire, the F-117 could perform precise maneuvers without sacrificing stealth. First flown in combat during the Gulf War, the F-117's stealth capabilities changed warfare. It demonstrated that highly defended targets could be reached without risking detection, giving the U.S. a tactical advantage that hadn't been seen before. Even though the F-117 retired in 2008, its engineering innovations live on. The breakthroughs in stealth technology, computer-aided design, and radar-absorbing materials paved the way for modern stealth aircraft, like the F-22 Raptor and F-35 Lightning. The F-117 Nighthawk was more than just an aircraft. It was a turning point in aviation engineering. Its design and stealth capabilities inspired a generation of engineers to think beyond what was possible. So next time you see a stealth fighter in action, remember that it all started with the F-117. Thanks for watching. And if you enjoyed this dive into engineering history, don't forget to like, subscribe, and hit the bell icon for more episodes on Warzone.